Alright, so here we are. So I have logged in into this. It says the zookeeper server is there. Now let me go back here. So alright, ad space is there. It says region server 0 of 3 alive. Alright, now it should turn up. Alright, so it says that there are two servers. Okay, all of them are up now. Okay, alright, going back here. So now status is up. And if you can see here, I forgot to show you that. So if the zookeeper is down, it basically does not turn up. So how it's trying to track which region servers are up is by asking the zookeeper again and again. And when we turned on these instances of region servers, they basically inform zookeeper that we are up. Okay. Now HBase is asking zookeeper, and they are informing zookeeper. So it's like a central broker. Okay. Now here we go again. So here we are. So we started the HBase shell, we checked the status, and then we are trying to create a table. Okay, let's create a table. So, okay, my table. Let's say we get a name called 2May. Okay, so it has created the table called 2May, and we have to define a column family. If we do not define a column family, it gives an error. Okay, it says that it will give an error. Table must at least have one column family. You can see that. Also, to see the list of table, you can simply say list. These are the list of tables available in the database. We can also say ls dot star and say tab and then dot star. So basically we can use our regular expression like this. Not ls but list. So you can see this. So wherever tab was found, it gave the results. So you can use the regex to get the list. Now we created a table called May to May. Okay. Now we want to add we want to this table we want to add this particular row having this column and this value. Now you can see that in the column we are mentioning the column family name. That's how it is. Okay. We are saying that in this table add a row with this row ID, and for this particular column family add one column called column 1 and add this value. Okay, so you can say scan. See that? Alright, that's another table, not our table. Now, if I have to get this data, I can simply also say there's too many rows. I created too many rows once. Alright, let it finish. So to get the data, we define that this is my table, this is my row, and this is my column, and it'll give you the detail. I've pressed Control C. I hope it does not exit. All right. Okay. So you can say HBase shell again and start. You can see that it has got you the value. Okay. So we gave while putting the data, we specified table name, row name, and then column name. And while getting the data, we specify table name, row name, and the column name. We got the data, whatever we have put. And we also can see that what does it mean by what does each table mean. So you can see that it shows you that this particular table has these column family and all other details, for this. Okay. To delete the data, what you have to do is you have to say uh, disable first and then delete the table. Like here, here, you can say disable and then you can delete the table. Alright. So now it's deleted. Also, to see the status of the server, you can use this particular port. You can use that particular port and it will show you the status of master. You can see. So for this server, these are the region servers available. Each region server is having some number of regions. Okay. And if you want to have really high availability, you might have to create a backup masters. Okay. And that way you should be able to okay, that way you will be able to handle a really high availability. These are the tables with the columns and yeah. All right. Now if you are a Java guy, you might want to, you know write something in Java. So here, is there a script? So you might want to use Java, and this basically program says that create a configuration, then admin, then table descriptor HDD, and then column descriptor. Then you add table, add a column family here. And after creating column family, you can basically, once you have created column family using admin, then you can basically check whether the table has been created or not. So you can create a add a while creating a table descriptor, you add the family and then create this particular table, whatever you have decided, and so on. Okay. All right. So that's pretty much. So you can go through this. All right. Any questions? Okay, so the way we were doing MapReduce on tables, we can also do sorry, we were doing MapReduce earlier on the HDFS files. Similarly, we can do MapReduce on top of any table. Okay. So earlier when we were doing a MapReduce on file, we were basically reading line by line. Here we'll be reading one record at a time, meaning one row at a time, and the input data instead of a file will be the table. Okay, a range of rows inside the table. So you define a mapper, you create a function called map, you get row in the input, and then once you are done, you write the data into context key value pair, and once then done, you write a reducer by extending table reducer. You get key and the values here, whatever it was there, and then in context you write the results. Once that is done, you tie them together by creating a config, creating a job config. Then you also define a scan, and that scan whatever scan you are defining, say starting point, end point, and so on, you can say here, okay, this is the job. It says that this is my source table on which we'll be running MapReduce. This is the scan, the reason on which we have to run the scan, and this is my mapper class. These are the data types, and this is my reducer class, and so on. And then wait for completion equals true. So it under the hood, it basically starts MapReduce, our traditional MapReduce, feeding our HBase HBase table instead of HDFS file. Okay. All right. So there is a concept called Bloom filter. This is needed because lots of people ask these things during interviews. Okay. How many of you have already heard about Bloom filter? Anybody? Hmm? No? Okay. So, all right. So, Bloom filter is an idea whenever you are doing a search or scan, and basically you want to delegate this searching or scanning to multiple machines. Okay. So that's when you generally use Bloom filter. So the way the Bloom filter works is, so imagine this, that in your organization, or in let's say there is a hiring drive, and thousands of people have been invited, and but here there is a line of 10,000 people. Okay, now there is only a single gatekeeper who is given a big register, that when a person comes and asks for entry, wants to enter the premises, just look up in the register, and if his name is found in the register, then only you let him enter. Now there are 10,000 people and there is a single person. So either we keep multiple registers, right, and multiple gatekeepers, but in those cases you will have to continuously update multiple registers, correct? Registers here, I'm not talking about the electronics component register. Here I'm talking about the here I'm talking about register as your physical paper copy. So now creating multiple registers this way is not an easy task, okay? Because the registers itself are big and copying it will be too big a task and so on. So you have a single register. So what do you do in such circumstances? Okay, what do you do in such circumstances? So what you come up with an idea that you will have a secondary register, a very rudimentary register, in which in which you will just mention first two letters of the name of the people who have been invited. Imagine this, just another register, and it'll have only first two letters. Now if the so now imagine now can somebody help me understand how many names will be there with only two characters? How many total names will be there with only two characters? Maximum number of names? 26 by 26. Perfect. Now if you see 26 by 26, 26 into 26 is how much? 576. So 576 is not a very big list of numbers, right? So a list of names. So all you did was you basically pick up first two letters of all the names that are in register and created a new register with only first two letters of each name, and you deduplicated them. So at most there will be 576 names, 26 into 26, correct? Now this new list is what we call a Bloom filter. So all these 10,000 people will be quickly checked against this smaller list. Only if their name is found in this smaller list, meaning we are just checking first two letters of their names, and once some people qualify by this particular register, if their name is matching, first two letters are matching, only then the request goes to the main person. Okay, now you can see that we have really offloaded our existing person, so that because the now the when imagine that for okay. So let's say in our database there was one person called Sandeep, other was Sanjeev, and third one was Sajid. Imagine that. Okay, and there is a person. So this is our database. So all of these, and let's say Srinivas. Okay, Srinivas. Now out of this we will have how many? SA and SR. This will be the two. This is the our original register containing only four names. Here the secondary register will have only these two names. And when say Sankalp comes, okay. So this is our you can say Bloom filter, and this is our Bloom filter, and this is our original database. Okay. So when Sankalp comes in and he checks the Bloom filter, check the Bloom filter. Okay. And so Bloom filter will say yes, because Bloom Sankalp is found in Bloom filter, but then the request will go to original DB, and original DB will say the Sankalp do not exist. Okay. So and if somebody called i- so it's the same thing. So if key 1 is found in the filter, and filter will generally say no. But if filter says no, that means there is no reason to go to main storage, right? If let's say somebody comes up, if let's say in the case 1, which is we are discussing, give me a name, say Baswaraz, okay? So when Baswaraz, the first two letters are BA, and BA does not exist in our list, so Bloom filter will itself reject it. So first case is Baswaraz comes in and asks that, hey, am I in the list? It says no. So if it's no, then it's no. There's no reason to go to the main storage. But if it is yes, then it has to be doubly checked, and then the response has to give in. Okay. So the strategy is clear to you, right? Now, what it looks like here, that for a user whose whose name is found in the list, there are two times checking happening here. We are checking that user two times. First on the filter level, second on the main storage level. Correct? For these two, you see the request is going till the end. Okay. Once so this one is a false positive, this one is a really positive. We found that key in the main storage. Here we found the key on the filter level, but it was not there on the main one. Okay. So in our case, if Baswaraj comes here, the filter rejects. But in case Sankalp comes here, filter accepts and does not, and then it gives an error. But if Sandeep comes here, it first checks, filter says yes, and then actual request goes, and in that it will find this, right? So is Bloom filter clear to you? On what basis Bloom filter is created? Very good point, Kalyan. Thank you. Right now, in this example, if you see, the way we have created Bloom filter is just first two letters. It could be really, really complex one, and it could be really, really uh, good one. Okay. So basically, the way Bloom filter is created is generally based on hash code. Okay. Meaning similar looking names, if there are very frequently similar looking names, we should not end up having too many requests to the original database. We should not end up having too many requests. So the way here what's happening is we should not have all the requests going to the storage. Otherwise, the purpose of filter will be totally lost. In our case, if we have filter only on first letter, meaning we, instead of two letters as a list, we have only one letter, right? A to Z, which means almost everybody will pass through and almost everybody will reach the storage. Correct? But if you have more than three letters, that means the work of the Bloom filter will be too much. So you have to take that call by defining a Bloom filter which creates the index of a very small size, but also does not lead to too many requests to the main storage. Very good question. Now, what is the advantage of Bloom filter? Now, in this example, can you see the benefit? So, lot of load is being handled by the filter. Filter itself is rejecting a lot of load, and this rejection The generally whenever people are querying your database, generally the rejection is around 95%. Okay, so Bloom filter is able to reduce your load to 5%, meaning it has reduced your total load by 95% by rejecting lots of requests in the beginning itself. And that's exactly the advantage of the Bloom filter. Now, Kalyan's question is, I mean the criteria for Bloom filter creation. The reason is, for example, if Bloom filter rejects and if it presents in the storage, yes. Yeah. So there is, we have to make sure that Bloom filter does not do those kind of things. Ideally, there will be no such Bloom filter which there will be no such Bloom filter where Bloom filter rejected the data while the data actually exists in the database. Okay? That should be strictly that way you should never design your Bloom filter. Okay? You should never design your Bloom filter such that Bloom filter rejected but your data exists. So that is the basic premise, that it should not be that way. It should be that way. If Bloom filter said no, then it is strictly no. If Bloom filter say yes, it then that means the data may be there in the storage. All right? Yeah. So generally, the it is basically the Bloom filter is based on hash code. If you have heard about hash code, so we basically convert each big string into a number. Say sum up all the numbers, then divided by 26. Whatever is the remainder becomes our Bloom hash code or key for the Bloom filter. Okay. And the Bloom filter also decided on such that this hash function is decided such that the result of hashing, overall result of hashing, should be, very small size, such that it can be loaded into the memory. Okay. So also it internally, in case of HBase, it internally creates Bloom filter on row key. Okay, it internally creates Bloom filter on the row key, so you don't have to worry about how to create a Bloom filter and how to use it, because it's automatically taken care by HBase. Okay, so you don't have to worry too much about the Bloom filter. Now, that's how you generally think about it, Srinivas. That's correct. Okay. And if you have to fit something in memory and you are dealing with hundreds of terabytes of data, then you should come up with a small set of keys, right? A small set of data. You should be able to, just pick up parts of data or prepare the data such that it can be cached into the memory or kept in the memory. All right, great. Now there is an idea called coprocessors. Those who are interested in coprocessors and might want to have a look at this. So, have any of you used something called triggers in databases, in traditional databases? Srinivas has used. Okay. What does it mean by a trigger? Trigger means on a certain circumstance, it executes your logic. Those circumstances could be when user creates a table, when a row is added, row is deleted, or row is updated, then that logic gets executed. So, but that's what is known as coprocessor also. Those who are interested in looking it up, they can have a look at it. So you can create basically class. Okay, you can create a public class like this, which extends a particular coprocessor, and then you can say pre this post this, pre this post this, pre delete post delete, pre put post put. So your function, whenever user is calling get, before giving the data to the user, your pre-get function will be called. And if you say don't give the data to the user, then user will not receive the data. So pre-get will be called, and you can throw an access denied option and don't let the user access the data. Post get, you can do things like after user has received the data, you can basically trigger something else, that something other event. Okay. Also in pre-get, what you can do is you can basically clean up the data, okay, and give it to the user. So basically these are triggers that give you the finer control over the user behavior using coprocessors. So before and after something happens, you can create a coprocessor and can get executed. Now the way to so once you have written your coprocessor, you can create the jar the way we had created earlier. And once you have created the jar, you can either update hbase config file and reload the server. Okay, you can basically update the hbase file in which you mention your class name as well and reload the server. Then your coprocessor will be hooked at various places like pre-get, post-get, and whatever is your decision, it will get executed. Now the other way is because that one involves rebooting the database, which is not generally an option. So what you can do is you can also put as a attribute to a column, and you can put a there is in HBase table, HBase has come up with something called table attribute, and in that table attribute you can mention that this is my class name, and that will get executed. Okay, so if you basically put set value here, and if you mention the name cursor coprocessor $1, then whatever path name of your class you give, then that will get executed. Okay, path is the absolute path in HDFS with the separator and your jar file that will get executed. Okay, so this way you can get your coprocessor executed. All right. Now some of you might be interested in using HBase as REST API. That you can do. It's very important to do that. Okay. Why? Because say you have some data in HBase and you want to present the web application, you can basically directly call your HBase service from the web application. All right, and this is the general URL definition. Generally URL begins with a scheme. A scheme could be HTTP, HTTP, HTTPS, FTP, or there are so many schemes out there. And the URL, the second part of the URL is the authority, meaning authority means server and the port and the login and the password. So user colon password at the rate at domain name colon the port name. Then comes the path. Okay. After that, the final URL, which is the key value pairs and so on. And the fragment is something which hardly reaches the server, the after hash. This is the standard definition of a URL. Okay, so you can start your HBase server, HBase REST protocol. Okay, you can start on this particular port, and then what you can do is you can basically make a call to your table. Okay, you can make a call to your table. So my table row 1 column 1, not this, not localhost this. We have Hadoop 1 dot no big data dot com, and the port number is, so it says table not found, correct? Now we can say scan or enable our table, or enable my table to may. Okay, so table, my table, oh, we have already deleted it. Okay, so let's say list, so we can say there is a customer table or first table, let's say first table, scan first table. So I'm just copying the first table from here. First table, row 1, what's the row 1? My RK, column 1 CF, and what is the column name? Column 1. So you can see that. So it has given you the data, column value, correct? And that's what is the data here, you can see. Alright, so now this kind of data you can basically query from here. Okay. Alright, any questions on this? In the same way, you can make a put call and put the data. So no, there's no relation between coprocessor and Bloom filter. Bloom filters are internal activities, while coprocessor is basically, sorry, Bloom filter is something, internally, which is a part of design of HBase, and you have no say in it, while coprocessor is something you define. The reason why a coprocessor cannot act like a Bloom filter is because if you have coprocessor, right, and you are, say, implementing pre-get, so before getting you want to return the data, so you have already reached the server, right, for getting the data. Now, even if you implemented something like a Bloom filter in pre-get, what will happen is that the request has already reached. So the main purpose of a Bloom filter was to avoid getting hit by too many requests, avoid hitting the region servers there or HBase master, right? But in case of coprocessor, if you try to implement, the purpose is defeated because request has already overloaded your machine, right? That's the reason, yeah. All right. Those who are interested in accessing HBase with JDBC can use Phoenix, and that can be quite useful to you. All right. That's pretty much about today, although today's session has been pretty short. Okay. All right. But I hope whatever we discuss, it's clear to all of you. So yeah, that's pretty much for HBase. Do you have any questions before we move ahead? Also, I'll before leaving, let's discuss the question which I has planned for today. And the question is here. Okay. So the assignment for today is if you have to design a simple Gmail like storage, okay? So imagine you have to design the Gmail kind of a storage, okay? What will be your table name? How many tables will be there? Okay. Also try to avoid, do not think of the advanced features of Gmail. like labeling, don't do labeling, stars and drafts, don't do that. Okay, only the inbox part, try to represent that. And also imagine that there are millions of users. All of the all of those users have to come to your database, get their email, and then when they reply, they will be adding an email. Frequently, there will be another service running which will which will receive the data and will also write into the same table. Okay, so one is the user is deleting or updating the emails or creating the emails for each other, and then there is another person who's there's another service which is basically continuously receiving the email and adding into this table. Okay, so there is every person has an email ID. Okay, and so on. So if you have to design this kind of storage, what will you do? Here the question is not, the question is not concrete. The question is more of an architecture question. Based on the data model, what we have learned today, what are the things you're going to do? Okay, what will be the tables? And in each table, what will be the column families? What is the row key? Under each column families, what are the columns? Then the approach you will have to write that if a user is sending an email, I will add this row and we'll have this. Okay. So come up with that design in HBase and that should be good enough. Okay. Here the answer will be theoretical, which is okay. All right. Okay, so that's pretty much for today. We will take care of Zookeeper tomorrow, Zookeeper and few more topics tomorrow, and then we'll go ahead with the further discussions. All right. Okay, then have a great day, and thank you very much. Bye bye. Thank you, Lakshmikant. I hope that I was able to explain the topics. Okay. So after this, you will receive questions, feedback on the session. Please fill that. And yeah, okay. Thank you very much. Now I will hang up. All right. If you have any questions, we can still have 5 more minutes discussion because we started a bit late today. All right. Thank you very much. Have a great day ahead. Bye bye. So no questions. Okay. So those who have questions, just drop me an email and then we can have further discussions. Okay. Thank you very much.